All right, welcome everyone. For part two of our lecture, we're going to be talking about class and instance level methods. We'll talk about the data flow of how data is being stored inside of each independent component, whether it's at the class level or the instance level, how methods are being triggered. And then finally, we'll go ahead and talk about static methods. So let's do a quick review over what we have up to this point. Up to this point, we've been working with the task application. Here we can see that we have some class level attributes such as past IDs, the owner, and our default Boolean variable. We were able to create a couple of methods here, or specifically just one method, which is for creating an ID. And we're actually going to mutate this method a little bit here. All right. So let's get started. Now we're talking about class level or instance level methods. Well, a quick instance level method for a task, I would assume, would be to change the task completed value, right? So I can do def. This is, again, a instance method. I can say change completed status. That takes in self. And all it's going to do is it's going to mark self.completed equal to not self.completed. That way I can change back and forth. All right, a couple of things to annotate here. This is an instance level method because I can see there's no decorators added. It is nested within the class, meaning it's not a function, but is a method. And the keyword that's being passed into this method is self. All right. So there's my instance level method. Let's see what it looks like in practice. Right, instead of changing everything up there, all I'm going to do is come down here. I'm actually going to copy and paste this information. But I am going to change task 2 status. And here you can see I have the change completed status. Now, because it is a method, I am calling the method itself. Just like a function would. But now let's run python main.py. When I execute it, you can see that all of them are false in the first iteration. And in the second iteration, we have false, true, and false. So I was able to change the current status. Now I'm not changing the status for all of them. I am only changing it for one specific instance, meaning that it still interacts with a unique value of classes. Or excuse me, independent instances. All right, we've seen this before. We saw it yesterday, so we should be a little bit more familiar with how instance level methods work. But now let's talk about class level methods. Well, currently the way I'm constructing a new task is by calling it manually. But let's say I want to isolate this behavior. I want to provide a way to create a new task and also be able to track that task. So I'm going to go back to my blueprint here. And I'm going to add a couple of values. here in my blueprint, I want to add the ability to create a task, which should be a class level method. And I also want to add a dictionary named all tasks, which will be global. Okay. Down below, we already created a method named change status, or excuse me, I think we named it change comp status. We know that is a instance level method. And this one interacts uniquely with only one instance. Well, eventually, I probably want to create a method that can interact with all of them. So change all tasks to completed, or change all tasks to not completed. All right. It's a little bit of behavior that I want to add to my blueprint. Let's see how we can do that. So I'm going to go back to the tasks. Here's my instance level task, or my instance level method. Now I'm going to go ahead and dive into my class level methods. Now I'm going to build it like a regular method first. I'm going to say, here's my method definition. It's going to be create a task that will take in self, and then it's going to take in data represented as a dictionary. All right. Now, what I'm going to do here is I am actually going to create the task. So new task is equal to tasks. And then I'm going to destructure the data that comes in. Now, this is some new syntax. What we're expecting here is we are expecting a dictionary that holds title with a title. And that also holds completed with some sort of Boolean variable or none. Let's go with true for this example. What this star star is going to do is it's going to destructure this dictionary and turn it into title is equals to parentheses, and completed is equal to true. Just as if we were passing key positional arguments like we did yesterday. All right, this is called destructuring of a dictionary. All right. Well, now finally, I want to save this task. Well, let's take it one step at a time, and let's make sure this works. It's going to return the new task that is being created. Well, as of now, this is for an instance. So if I try to, what I'm essentially saying is that an instance of a task can create other tasks. Well, that's not necessarily the behavior that I want. So instead, I need to turn this into a class method. Well, how do I do this? One, I need a decorator to mark the class method. And two, I need to exchange the keyword of self for CLS, because self is to describe the instance itself, while CLS is utilized to describe the class itself. All right. So let's make those changes. Here, I'm going to bring in at class method. This is what turns it into a method that can be utilized by the class. And instead of self, I'm going to utilize CLS. I don't have to call the class down here. I can call CLS because, again, CLS is a reference to the class itself. So I am constructing a new tasks. And that's what I am going to output will be tasks, which it won't let me do that here. So we'll have to leave it as such. All right. Let's make sure this method works. Instead of task one being created this way, what I'm going to do is I'm going to say tasks dot create a task. I'm going to pass in that code. And I just simply want to print the value of task 2. Okay, so I see task.task argument after ... must be mapping, not a string. Okay, so I made an error there because what we're expecting is a dictionary. So let me go ahead and fix that. Now we can see that I was able to create a task just by passing in the correct dictionary. If I wanted to pass in something else, I can also pass in something like, hey, completed. And here for the completed value, let's do false. You can see it all works properly. Fantastic. Now, this isn't really any different than the constructors that I had before, right? It's essentially just calling the init method. So why did I even go through the process of creating this? Well, let's go to creating another class level attribute named all tasks, which will be a dictionary, and we'll set to an empty dictionary for now. Now, when this new task is created down below, I can say CLS dot all tasks with the key of the new task dot task ID is equal to new task. And then I can return the task. Well, what does this do? Right? What benefit did adding this one line of code really do for me? Let's take a look here. I'm going to print tasks dot all tasks before, and then I'm going to print it after. Let me clear my terminal here and then execute this script. Oh, I apologize. My first print statement should have been up there. Okay, so let's do Python main.py. So we can see that before the create task class method is being called, all tasks is an empty dictionary. After it is called, we can make sure that our information is actually created. We see that down below here. And then finally, when we print all tasks in, we'll now have a key value pair where for every task being generated, I am also creating an instance of the task. All right. Again, my class level method is here. I am creating this. This IDs portion that we have down below, since it interacts specifically on a global environment because it's actually interacting with past IDs, this here should also be a class level method. Right? This isn't something that I want just an instance to be able to interact with. I want an instance to be able to call it, but not change the value of past IDs. So I need to isolate that behavior by just changing this to at class method. Again, wherever we see self, we change this to CLS. CLS still has access to the past IDs. Fantastic. We can see that the new ID is still added to the past IDs, and then a new ID is still returned. So nothing should break. If I run this, everything still works properly. Right? Because we're interacting with something in a global scope, it should be a class method. A general rule of thumb is I just ask myself, should a task be able to alter or create something that every other task is needs? And if the answer is no, then there should be an instance method. If the answer is yes, then there should be a class method. All right. Does anyone have any questions between the difference of class and instance methods? Let's hear it, Tony.
Yeah, it's more for this car manager assignment. So I structured it in a list, but would it if I was to use this, I would need to probably do that as a dictionary versus a list. As
You
far as
can.
like the car IDs and the services, stuff like that, or
You could manage it that way. It would definitely be cleaner to store it within a dictionary. But you could also store it within a list and then just create a finder so that you can iterate through the list until you find the correct ID and then bring out that one object.
okay.
All right, Arnold.
So I put in the cart manager dot all cars self ID, the key, basically the dictionary inside the def init, so that whenever I run the methods and stuff, it would just automatically get the whatever you put in. Does that work or no?
I'm sorry, could you say that one more time? Are you asking about the car manager or are you asking about this example here?
Can I show my screen?
Sure. Let me go ahead and pause the recording here. All right. So it looks like no one has any questions regarding this class method. Classes are being able to be generated. Again, CLS is the representation of the class itself. That's why here in new task, we're able to pass in CLS. This star star is essentially just destructuring the dictionary so that what we can pass in by key value pairs or by key positional arguments, just like we saw yesterday. It's an exchange. And because our create IDs interacts with the global scope of past IDs, we created it into a class method. And I see a hand go up. Go ahead, Tony.
Yeah, so I guess my only confusion is where the data comes from. Is that just based on the method below where you're creating the task, or like, sorry, let me see.
Where the data comes from. Okay, yeah.
Where does this come from? Like
Got
which
it.
data is it referencing?
Yeah, so that's happening here in main.py. It's referencing the dictionary that's being passed in to the actual method of created tasks. So that is the value that's being passed in as data. In task.py, we can see that we're looking for the argument of data. And that's what's being destructured down below. All right, see the thumbs up. Perfect. Well, let's finish off our behaviors here. I want to change all tasks to completed, or I want to change all tasks to not completed. So I'm just going to create two other methods. And at this point, I would like you guys to go ahead and help me create this method. So I'm going to just randomly call people. I'm going to be creating a class method. So what kind of decorator would I need? Bryson?
Sorry, one more time.
I'm going to be creating a class method. So what kind of decorator would I need?
Honestly, I don't have an answer.
Okay, awesome. No problem at all. Let me go ahead and pass it on to Arnold.
Is it hello?
There you go. Sorry, could you say that one more time?
Hello?
Yes.
So as a decorator, like you define it, and then I don't know what we're gonna be making a task with.
Okay, so I'm
And
making a method, right? And this one's going to be update all tasks to completed. Now, for this method, what decorator am I looking for? And what keyword am I going to be passing into?
so here in the lesson, it should be a wrapper, but it has to be like a wrap, some type of what you wrap it with. Uh, create a task.
Let me go ahead and pass it on to someone else, Arnold. Let's pass it on to Tom.
Yes, sir. You'll need a at class method.
Awesome. So on line 74, I'll go ahead and add this at class method. And then the keyword that I would need would be what, Tom?
CLS.
Perfect. I need CLS. All right. So now update all tasks to complete will be a class level method. We can see here at CLS. And what I want to do is I want to grab all the values of the dictionary. That's all tasks. Now, how could I grab the dictionary of all tasks? And I'm going to pass that on to Angel.
To grab all the tasks. This is in the decorator.
So this is no longer in the decorator. Now we're within the actual body of the method. And all I want to do is I want to grab the attribute all tasks.
So do we have to do I might be wrong, but do we have to do a wrapper with the task name inside the parentheses or?
No, we do not need a wrapper. No.
I'm not entirely sure at this time then.
Okay, awesome. Let me go ahead and pass it off to Alex then.
Can you scroll up to see we're trying to access all tasks dictionary is okay, it's a class attribute.
Yes.
Okay. We would then do to access it, we would maybe do we would we call the class? What are we on? Tasks dot all tasks.
All right, awesome. So that gives me all of my tasks. All right, and I could call the class itself, but remember, CLS is a keyword that references the task. So we could just exchange this for CLS. Since it's a class level method, it will access the all tasks. Great, so now we have all of our tasks, which is our dictionary. Inside of our dictionary, we know that we have key value pairs, where the key is the integer ID, and the value is the instance of a task. Okay, so now how could I grab all the values out of this dictionary? And I'm going to go ahead and pass that one over to Chris.
Yeah, I like to say it's like you got the key and the value, or like dot keys or dot values.
Awesome. So I can just say all tasks values, or let's just call them instant because that's what we're grabbing. And we can say all tasks dot values, right? Because that's going to grab all of the values inside of that dictionary. Great. So now what we're looking at will be a array for every task instance. Awesome. So now I have all of my task values inside of an array. All I need to do now is iterate through every single one of those tasks and trigger this change completed status. Actually, I wouldn't even be triggering this change completed status. I would actually be iterating and manually changing their completed status, right? Because I want all of them to be set to true. So how could I do that? Let me go ahead and pass this one off to Ryan. How can I iterate through all of the task instances?
Give me 1 second. I'm thinking. Would it be return all task instances?
Okay, so in the end, you want to return something. I'm gonna go ahead and put that as pseudocode, where we want to return all task instances. I'm seeing a hand up. Go ahead, Arnold.
Sorry, so just to go back, so decorators are literally just the property and the property dot setter. Because is that just for clarification?
So decorators, the definition of a decorator is a function that takes in a function, right? And it alters the behavior of the following method or function. The decorators that we have available that we're utilizing within OOP as of now are the property decorator, the setter decorator,
Oh,
and
okay.
the class method decorator.
Oh, okay. Yeah, I guess I missed that part. So anyway, it's gonna be for task and all task instances.
All right, let's do for task instance in all tasks instances.
Print task instances if you wanna iterate through them.
Okay, so that would iterate through them, right? But what we want to do is we want to change their completed value to true. So how could we do that? And let me pass that part off to Sam.
So first the thing in task instance would be true, like task instance equals true, but there's two values to each key, right? So it would be
So
task instance at 1 equals true, like bracket 1.
So currently we're interacting with every task instance. So this is the information that we're interacting with here. All right, just this here. And what we want to do is we want to change one of these attributes down below to be equal to true.
Mm-hmm. So it'd
Right.
be task instance at 2, like bracket 2.
We wouldn't be utilizing any brackets anymore. We're within the instance itself. So everything's in dot notation. Right? Which one of these attributes is it that we want to access?
Dot completed.
Okay, so we would do task instance dot completed is equal to true. And let me make sure that that's what we named it as well. Okay, that is what we named it. We named it dot completed. And we set it to true. Fantastic. Now, instead of this return statement, I'm going to go ahead and return all tasks are now set to true. Okay, let's make sure this works. We're going to go into main.py and we're going to create a couple of other instances here. Let me close this up, give myself a little bit more space. Here we have task 1, and here we have task 3. Okay. So now, when I go to create, let's do code some less, code some more. Finally get some sleep. And I'm going to go ahead and print all of my tasks when this is executed. So I can see that task 1 was created, task 2 was created, task 3 was created, and so on. Right? If I wanted to, I could access them by the key. I can say, hey, I want to grab where a key of 1, and that would return to me. Okay, we can see that code some less is there and it's false. If I want to grab the key of 2, that would also work. And then finally, if I want to grab the key of 3, that also works. So all 3 of my IDs are placed. I can grab them straight out of the dictionary. Fantastic. Well, now let's go ahead and type in where tasks dot update all tasks to completed, and then print tasks dot all tasks dot get. Let's do 1. Okay, so now instead of being false, it's true, just like we wanted it to be. Again, instead of being false, it's true for task 2. And if we execute it again, we can see that instead of being false, it's true for task 3. All right. So we were able to create a class level method that updates all of the tasks. Now let's talk about our final class level method. This one will set all to false. So I'll just go ahead and start us off. So I'll say update all tasks to false or to not completed. Let's do incomplete. Okay, awesome. So now this is supposed to be a class level method. How can I make sure that this is a class level method, Rick?
Yeah, got me. All right, so you would start out with above that, you would go at class method.
All right, fantastic. And what word should I pass in there?
So you would pass, well, you would pass CLS because it's a class, because it's within the class, I mean. And then, yeah, you could pass it, but yeah, just like before, you just do like, basically exactly what you got, all task, semicolon, dictionary.
Okay, well, let me go ahead and let's save us some time, right? Let's do a list
Yeah,
of
a
CLS.
list.
And what we're
Okay.
going to do is we're going to grab all tasks dot values. Awesome. So now we're up to this point. And you said to do the same thing, so I'm just going to go ahead and do my for loop now.
Yep, the for loop, yeah.
Like
Except you've got a different variable now. Well,
That's
wouldn't it
right.
be a
Yeah.
different variable? Yeah.
It would be, yeah. I'm utilizing all tasks now. Okay,
Yeah,
so
so
there
it'd
we
be
go.
all task and what's that? Oh, okay,
Oh,
you got
go
it.
ahead.
Yeah. No, you fixed what I was saying. But the task, so for task int, that would be you're actually iterating through all yeah, there you go. All tasks. Okay. Yeah, so int dot completed equals false. And
Nice.
then
That
you
looks
could
good.
just return. Yep, there you go, return. All tasks are now incomplete.
All right, awesome.
What a man.
So now we can go ahead and change these again. Let's do tasks dot update all tasks to incomplete. There's no position arguments that we need to pass there. So now if I execute it, we can see it goes false, true, after all tasks are marked to completed, and then false yet again. If I change all of these to 2, again, we can see false, true, and false. And if I change them all to my last task, which in this case would be 1, we can see false, true, and false. All right, so all of our tasks are being able to be manipulated because it is a method that interacts with multiple instances. Then we can make sure that it is a class level method. So another way to take a look at this boxes inside of boxes method here, I like to break it down in this way as well. It's more of like an octopus way, where every instance can be related to the class. All right, so there we have our class declaration with all of its class attributes and methods. And we have our instance attributes and methods. An instance can access class level information. And a class should not be able to access independent, unique information unless it has to by interacting with multiple instances. All right. Here we can see the encompassing of it. Kind of like the parent-child relationship, where the declaration of the class is the parent and the instance of the class is the child. And then up above here, we were talking about how we can define where all instances, in this case, multiple dogs, would all be a German Shepherd, would all have 4 legs, and would all have an average lifespan to be the same. All right. Let's go ahead and do a quick recap of this class here. Again, we went ahead and created the class tasks. Here are all the class level methods. Something also important to point out here is no getters and setters are being created. Right here we have our instance level methods. Where getters and setters are common. Here's all of our getters and setters where they start. All right, here's our instance level method. And then our class level methods, all marked by the decorator of class method with the keyword of CLS. All right, and I see a hand go up. Go ahead, Alex.
So at the top, you also put class level methods, I believe. Are those methods or attributes?
I apologize. I meant to put attributes. Thank you for
Okay.
catching that. All right. Any other questions? Okay, great. There's one more thing we have to cover today, and that's going to be something called static methods. Now, I left static methods for the very end on purpose. Although they are useful to know, they can be very confusing. So if you feel burnt out and you need to disconnect, this is the time to do so. And then you could just come back and rewatch this portion at a different time. So we've talked about all this class and instance and how they relate to one another, right? An instance level method should only interact with unique attributes to the instance. A class level method interacts with multiple instances. or with information only to the class. Now, when it comes to static methods, for lack of better words, they're kind of like the little one-off child that nobody ever really uses or likes, and they're all off to the side on their lonesome. And static methods are unique in the fact that they don't necessarily have to interact with instance, nor do they have to interact with the class, but they are common to the concept of a task. So for example, let's say I'm working through this. I want to start building some static methods. Oh no, this thing started again. Static methods are marked by a decorator. They do not have to, but may interact, not change values of instances or class attributes. Mainly used for read purposes. So for example, let's say I want to create some sort of menu that will manage all of these tasks. Well, that's a pretty good example of a static method. It's something that doesn't necessarily have to interact with tasks in general. It could just be calling upon the different methods within the class. So if I want to do @static method, and here I can say that I want to build a task menu. Now, a static method doesn't actually receive any arguments for the function because it's static. It does not fall within self. It does not fall within the class. It is just a static method. It falls right outside. And let me actually confirm that because I want to make sure I'm not giving you guys some wrong information there. Okay, good. Yeah. So a static method doesn't take an argument. Here we have our menu, right? I can say while true, or let's say run is equal to true. Say while run, maybe I have some sort of menu. Here I have option 1 for create task. Option 2 for update a task. Option 3 for update all tasks. And then finally option 4, which is exit. All right, well now I can say while run, print menu, or I can say input. Pass in the menu and ask if user input is equal to 4. Then I want to break out of the while loop. Else, we can say print user input was accepted. And then finally, hope you come again. Well, now I can go to main.py. And although it is a static method, it still belongs inside of the class. So in order to call it, I have to call it within the class. Oh, I think I'm returning, not printing. Let me make sure. Oh, no, I'm printing. All right, great. Well, let me close this off. I can come out here and clear this, and then Python main.py. Well, I can see that if I put in 1, it would tell me 1 was accepted. If I put in 2, we see 2 was accepted. 3 was accepted. And then finally 4 would kill the loop and print out, hope you come again. That is a static method. It runs the menu for the class. It's specifically to manage all of the tasks that are being created in this terminal application, but it doesn't interact or update that information. It could call these methods within it to update the information, but the static method itself doesn't do it or doesn't complete that function. Right? So that's why I said it could be a little confusing because it may or may not interact with class or instance attributes. It shouldn't be changing their values directly. It should be leveraging information that has already been made within the class or the instance to update values or delete values. And again, it's just kind of a weird little, for lack of better words, it's a little bastard child that just falls outside in the OOP. All right. At this point, does anyone have any questions over class, instance, or static methods? Go ahead, Rick.
Yeah, it's more of a, I guess it's a question. So yeah, if you're doing like a menu, create a task, update a task, that kind of thing. These actually, like you said, don't actually modify the 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 instance of the class, but it will call a property of the class. Like say you want to you call the setter for like create a task, it would call the setter and then it would run through the code of the setter, but the setter can actually modify the class by like adding, like in your case, adding a task. So the static method just calls your setters and your getters. Is that correct?
In this scenario, yes. Right? You could have a static method that doesn't do anything with your task other than just make a statement saying, hey, this is a task class and this is what it's supposed to do. It could just be an orientation. It doesn't have to interact with them, but in this example, that's correct. Right? We're utilizing the
Oh,
static method
but it
to leverage.
can. Yeah, it can access the setters and the getters, but it doesn't have to. All right.
All right. Any other questions? Okay, it doesn't seem like we have any questions. We've been going on for quite a while, so I'm sure we're all pretty burnt out as well. Let me go ahead and stop our recording here.